In our last video, we learned how to calculate mechanical advantage of a bolt or a screw if we were pinching with our fingers. We calculated it, and we got about, or almost 30. We got about 27.4, almost a mechanical advantage of 30, which is pretty big, but it's not really big enough, it turns out, to turn a screw into wood or a bolt into a car or whatever. Even though a mechanical advantage of 27 is still pretty big, you're gaining 27 times the strength. If you're just pinching it with your fingers, you're only getting 27 times stronger than your fingers, which still isn't enough to turn a screw into wood. So it turns out we need some extra leverage. So let's say we didn't just grab this with our fingers. Let's say we used an 8-inch wrench. So we have this 8-inch wrench, and it's grabbing onto this bolt, and it's twisting around. So if you think about it, if we have our circumference of our effort force, and we have the bolt in the center, well, the wrench, and I'll draw the wrench as a rectangle, but let me use a different color. The wrench will wrap around it and then spin around all the way. So it's not really 8 inches, or it is 8 inches, but it's not 8 inches in diameter. The 8 inches is only the radius. It's going to go another 8 inches to the other side, over here. Let's draw that 8 a little bit nicer, but yeah. And so that means the diameter would be 8 plus 8 is 16 inches. That both the radiuses will add up, or they'll double. Okay, so let's go ahead and get our equation out. I'm going to go ahead and just copy this one so I don't have to rewrite all that. It's going to be the exact same equation. The only difference is our circumference will change because we're taking a longer diameter. So I'm going to set that equal to the circumference divided by the pitch. Well, if we look at the number on bottom, it hasn't changed any. It's still the pitch is still the number of threads per inch, or it's 1/20th of an inch. And the number on top will be the circumference. Excuse me. Well, that's just pi times diameter, or 2 pi r. Well, we could use 8 inches and multiply that by 2 and get 16 times pi, or we could just say the diameter times pi, which is just pi times diameter 16 pi. Well, okay. Well, with that, we just plug that into our calculator. We could say, what's 16 times 3.14? And let's try typing it in where our decimal's in the right place. Times 3.14. There we go. We get 50.24, so we get equals 50.24 divided by 1/20 is just 0.05. So we take that number and divide it by 0.05. And we get a mechanical advantage of 1004.8. So let's say IMA equals 1004.8. And you might say, well, that's a huge mechanical advantage. And I'll say, well, yeah, because we got this huge lever multiplying by it. We get this increase of effort force that's gigantic. And you need that to turn a screw into wood, or to turn a bolt into a car engine, to hold everything down. You want that to be that powerful. That's kind of the idea. And you might say, well, Mr. Anderson, the IMA, that's pretty simple. We kind of figured it out. We've done a couple examples. What about the AMA? What about the AMA? Well, we know that it's FR divided by FE. So in this example, they actually gave me FR and FE. They gave me the FE is 35 pounds of force. I'm turning this wrench with 35 pounds of force. So FE on bottom is 35. And on top will be the amount of force that goes downward. That's the force resistance. Well, there's 1,200 pounds going down. Okay, so we type that into our calculator. We get 1,200 divided by 35. There we go. Now what do we get? We get an actual mechanical advantage of about 34.3. And then you might say, well, Mr. Anderson, those numbers are very, very different. We've got 34.3 on one hand, and on the other hand, we've got 1004.8. And those numbers are comparatively different. In fact, we can calculate exactly how much different they are by putting one on top and the other on bottom, 1004.8, and multiplying that by 100 to get our formula for efficiency. We get about 3.4%. So we multiply this by 100, and we'll get percent efficiency, which is 3.4%. So percent E equals 3.4%. You might say, well, why is the efficiency so low? And if you think about it, you're splitting wood with this screw that takes a lot of friction. There's a lot of force fighting you. Oops. So let's go ahead and make that note for ourselves. That screws have a very low efficiency because there's so much friction. So screws, make a little note for yourselves, screws have a very low efficiency because of so much friction. Let's go ahead and add a little dash there. And then we can start another note, and I'll do that in another color here. I'll put another dash. And this is a note we've already made, and that screws need a huge mechanical advantage. Because they need to be strong to split wood, or to maybe hold down a car engine or hold a tire on a car. So let's just say they need to be strong to split wood, etc. And strong might not be the most scientific term. They need the extra force, though. They need extra force to split wood, or to hold a tire on a car, or hold an engine down, or what have you. And that's how you calculate mechanical advantage of a screw.